everyone, welcome to my YouTube channel Study with Soumya. I hope you all are well and preparing for your placement exam. In this video, we are going to do the complete explanation of binary search algorithm along with the approach and implementation of the same using a programming language. So make sure to watch the complete video. Also do subscribe this channel if you haven't subscribed yet. We have noticed that many of the students watching the videos are not subscribing. Guys, please do subscribe. Please support us. Also do join our Telegram channel, that is Placement Forenge. So the link for the Telegram channel is given in the description itself. So you can join it from there. Let's start with the video now. Basically, what is the binary search algorithm? For example, you have an array like this, right? And you want to find an element. For example, you want to find 50. So what is the first method that you can use or that will be in your mind? Just simply iterating through all the elements present in the array. This is the first method that you can use, and this method is also known as linear search, right? I have the video regarding linear search on my YouTube channel. The link for the same is provided in the I button. So make sure to check this video first and then come to this video, right? So linear search algorithm follow the concept of going through each and every element of an array, right? So for example, you want to check for 50. So first we will go to 20, then 35, then 37, then 40, then 45, and then 50. So finally, when we'll reach to 50, we will stop iterating. So this is the funda that linear search algorithm use. Now, what is the time complexity for linear search? It depends on the number of elements that we do have in our array. For example, suppose this 50 is present at the last. So what is going to be the time complexity? It totally depends on the number of elements. So if n elements are there in our array, so it is going to be big O of n, right? Whenever defining an algorithm or whenever discussing about any algorithm, we mainly focus to optimize it as much as possible. That's why here comes a new algorithm, that is binary search. What it does, it divides the array into half and keep doing the same repeatedly. For example, but the most important condition for binary search is that array should be sorted. This is the most important condition. If your array is not sorted, binary search won't work, right? So this is the thing. So first your array should be sorted, as if this array that we do have here is sorted. Now what it does, for example, you want to look for let me explain you in the layman terms. For example, you want to search for a page number 215 in your notebook, right? You randomly open a page that is 124. Now you are aware of that all the pages in a book are sorted, right? So they are sorted. So for sure you won't move in the left of 24. Obviously you will move in the right. So what you have done, you have reduced your efforts. You are not going through each and every page of the book. Obviously it is very hectic process. You know that all the pages in a book are sorted. So that's why when you randomly came to this page number, so you will move to the right. So this is the same approach that binary search also follows, because here the array elements are sorted. This is what we are assuming, or this is what mandatory. For example, you want to look for 50, right? So what we will do here, we will divide our array into two parts, right? So what we will do, first we will calculate the middle element of our array. Calculation of middle element. What is the middle element for this array? So how to calculate the middle element? So simply take the first index and last index of your array divided by 2, that is 4. So the element located at the fourth index of array is going to be the middle element. So that is our middle element. Now suppose you want to look for 50. You are searching for 50, right? So what we will do in this algorithm, we will compare this 50 with 45. So if 50 is equal our middle element, then that's great. You find the element, you can simply print that this particular element is present at this index. But if in the case, what you can see here, 50 is greater than 45. So obviously array is sorted, so you don't have to move here in the left direction. So this much effort is reduced. Now you will move to the right direction. So basically what we are doing here, we are dividing our array into half. Now again we will calculate the middle element for this array, this sub array, right? And again we will compare, right? So again, what is the middle element for this one? That is 5, that is 8. So this 51 is going to be the middle element, right? So again we will compare 51 to 50. So 51 is greater than 50, so we will move to the left direction, and here we will find the 50. So 50 equal to 50, condition is true, so that is 50 is present in our array at particular index we will mention in the solution, right? So we are keep dividing our array up to the time we are not getting the element we are searching for, or if in the case we have gone through the whole array, if in the case we have gone through the whole array, so for this we are maintaining two pointers also, that is first and last. So if in the case the first value has been greater than last, we will come out of the loop and we can simply print that this particular element that we are looking for is not present in our array. What is the time complexity for this particular solution? First we have n, all the elements, then we are dividing this by 2, we are dividing our array into half, then we are repeatedly doing the same, right? N upon 2 by cube. Suppose we did that same up to the time n by 2k, right? So let's equate this n by 2k equal to 1. So n equal to, let me write here, so we will get n equal to 2 raised to k. On taking log, what you will get, let's take the log, it is going to give us log base 2n equal to k, right? So what is the time complexity, guys? So what is the time complexity for this one? Log n base 2, right? So see, in linear search we were having big O of n, now here we have big O of log n, right? So we have reduced the time complexity, and whenever solving or whenever learning an algorithm, this is our main agenda, to reduce the time complexity. I hope you understood the approach for binary search. Let's see the implementation of same using C++. So for example, we have an array ARR having elements 12, 34, 56, 67, 78, 90, right? Also remember the mandatory condition is that your array should be sorted. Whenever using a binary algorithm, binary search algorithm, it should be sorted. How many elements do we have? 1, 2, 3, 4, 5, 6, right? So let's take a variable and equal to 6. 6 here is denoting the size of our array, right? Let's take a variable s. So we will define a function binary search. We will pass array to this array. Let's suppose we want to check the element 67, or even you can do the same by taking the input from user. I know that you will be able to do the same, that's why I'm not showing how to do that. We can simply do this by using cin, right? So array ele, so ele, then 0. So see, our first pointer is at 0th index and last pointer is at last index, so n minus 1. We are passing all these values to our binary function, right? And what we will do here, so if s equal minus 1, that means the element is not present in the array, right? So in that case what we will do, cout element not found, right? Else if this is not the condition, cout element is present at the index s. Let me give some space, right? Now what we have to do, the actual thing comes here, we have to do the implementation of binary search. It's taking an array, okay, and element that we want to search for, lower element, right? So what to do here? So here we will run a loop up to the time the lower pointer is less than or equal to the upper pointer, right? Remember the condition we discussed when during the explanation of the algorithm. Now here we will calculate the middle element, right? So int mid equal to u plus l divide by 2, right? Now what we will check? We will check that if middle element of array is equal to the element that we are looking for, in that case what we will do? We will simply return mid, right? And if this is not the case, so in that case what we will do? So what are the two cases possible? That the middle element of array is less than the element that we are looking for. In that case we will move through the right subarray, right? So in this case what we will do? To move in the right subarray, our L should be updated as mid plus 1. Otherwise the middle element will be greater than element. In that case our upper should be updated as mid minus 1, right? And if the element that we are looking for is not present our array, so we will just come out of this loop and simply return minus 1, right? So we are good to go. So we can see 0, 1, 2, 3, 67 is present at index 3. So that's why we are getting that element is present at index 3. Now let's try for 78, right? Let's try for 78. So element is present at the index 4. So you can see 78 is present at index 4. Let's try for 100. So you can see 100 is not present here. So let's run. We are getting element not found, right? So I hope you understood the whole approach of binary search algorithm. Make sure to like the video. Make sure to subscribe this channel. Thank you so much. Bye bye.